Thank you everyone for joining the second sushi workshop here today. This one is going to be a deep dive into sushi. We have three great speakers here who are going to go over the three sushi challenges here for Hack Africa. And so for starting off, we have Ramin from Sushi to talk about the easy challenge. So if you have any questions, please do put those in chat and we'll be sure to get those answered here throughout the workshop.
All right. Should I start or should we?
Yes, you are good to start.
All right. Let me start with a short introduction. I'm Chili Chelly. I've been programming for, I think it's the last 13 years now. For the last 10 years, I've been mostly doing full stack, but the last 2.5 years were mainly React. I started working for SushiSwap since 2.5 months, and I'm doing all things related to front end. So I mainly work on the SushiSwap interface. If you want to know more about me, you can read the Medium article that got posted last week. It's a good read. I recommend it. If you guys have any questions, feel free to ping me on Twitter, which is Chili Chelly, or in Discord, which is Chili Chelly #7371. All right. So I will be hosting the first challenge, which will be about utilizing the Sushi AMM, which are contract or somewhere on your interface of your platform. Sarang will be hosting the second challenge about building a Dapp on BentoBox. BentoBox is the Sushi token vault that allows for dual token usage for Dapps built on it. Gasper will be hosting the third challenge, which will be about analytics. Sushi is proudly deployed on 17 chains, but there's no consolidated location to feel critical info such as TVL and volume. All right. As you guys know, SushiSwap is decentralized, meaning that our backend is not like a regular database, but is an EVM compatible network like Ethereum itself or Polygon. This means that we do not have any API endpoints that you can call to create a swap, which brings us to the next question. How do we create a swap on Sushi's exchange? Basically, to create a swap on Sushi's exchange, one needs to call a swap method on the Sushi router contract. And this router contract uses the SushiSwap liquidity pools under the hood. And these methods can either be called using JavaScript or in your own Solidity contract. I will explain this more thoroughly in a bit. I just want to give some background knowledge on React first. So this presentation will focus on React, which is the framework of choice for Sushi. Please note that this challenge does not require React, but as SushiSwap interface uses React and documentation is limited, SushiSwap interface can serve as an example on how to perform a swap. If you're not familiar with React, I highly advise you to learn it. It's a very valuable skill nowadays. I know Udemy has some nice courses, from which I learned React as well. So yeah. On the next slide, I will start explaining a very basic core concept in React that we use throughout the SushiSwap interface. So what we're seeing here is a functional component, which is just nothing more than a plain JavaScript function that takes an optional input, which are the props, and returns on JSX, which is just JavaScript that looks like HTML. Hooks are functions that we call inside React components. These do not return JSX, but just any data structure. Hooks can trigger re-renders of the components in which they are called. The following example shows a functional component and so what does the output here look like on an initial render? So count is initially set to 0. So if this function is run, this will print 0 and 2 buttons, increment and decrement. Oh, this should be decrement here. Every subsequent render, count will still print 0. So what happens if we click increment here? So if we click increment, we're calling set state here in the hook, and set state has some React magic under the hood that re-renders this function, which in turn re-renders this component. And as set state has updated state from 0 to 1 here, this count value updates. And so as this is re-rendered with this new count value, we have 1. This is just very fast on how components work with hooks. If anything about this concept is unclear, feel free to message me on Discord or DM me on Twitter or in the chat. For more elaborate documentation on React, please refer to the documentation itself. Yeah. So the next, this should have been like Web3 React. So how do we interact with EVM compatible networks from JavaScript? To interact with EVM compatible networks, we use a library which is called Web3. Web3 allows you to interact with local or remote EVM compatible nodes. We use Web3 React specifically because we're obviously using it in a React environment. So what if we want to call some write method on some contract? Where do we start? So if we're swapping, we're actually like writing on the Ethereum network. Well, when we call write methods on contracts, we will have to pay for gas. To pay for gas, we need to have a wallet connected. The easiest and most common one is probably MetaMask. I'm pretty sure you guys have all heard of MetaMask. Web3 React provides you with an injected connector class that does basically all the heavy lifting for you. So if you take a look at SRC connectors index.ts in SushiSwap interface, this should give you an idea on how to set up the injected connector. Yeah, so once we have a wallet connected, we can use a handy hook provided by Web3 React that is called use active Web3 React. And this hook exposes the account variable, which is just the wallet address as a string, alongside some other variables like chain ID and library. And the library is basically the provider, the JSON RPC provider. You'll probably recall me saying to create a swap on Sushi's exchange, one needs to call a swap method on the Sushi router contract. Well, to do so, we need to instantiate the contract first, which brings us to the next slide. How to call a contract function in JavaScript? Well, this is actually fairly straightforward. To instantiate a contract, we need to have 2 mandatory inputs, one of which is the address, so the contract address, which is basically self-explanatory, and the ABI. And the ABI stands for Application Binary Interface. This describes how you call functions and retrieve data in a contract. The ABI is just JSON syntax. As SushiSwap interface uses a lot of contracts, we set up some convenience React hooks that allow for easy integration of contracts. So this is actually a convenience hook. It's called use contract. You can just copy paste this if you're using a React context, that is. If you're not using React, then I guess this is the only line that's really that you need. This contract class is from Ether's project contracts. Oh, I didn't put that in here. Yeah, it's a library. It's called Ether's project contracts. I'll put it somewhere after this call. By the way, every snippet you see here is just from the SushiSwap interface repo, which is accessible by everyone. So you can just look at the repo anytime and just, yeah, you can find all of this in there. These hooks are just, yeah, we built these for code duplication to reduce that. So we have some checks built in, But all that matters here, if you're using vanilla.js, is actually like instantiating this contract. One tip, you'll need to be able to call functions of the router contract. So take a look at the router contract ABI to see what methods it offers. So far for the front end side of this challenge. So how do we perform a swap using a contract? Well, I created a very simple example. So let's say we want to try and create a triangular arbitrage bot on SushiSwap. Triangular in the sense that we will try to swap our E for sushi, our sushi for sake, our sake for USDC, and our USDC for sushi again, for small profit. We would use JavaScript to look for pool changes, and once a profitable opportunity arises, we call a function of our contract in JavaScript that will kickstart the bot by calling the swap function of the SushiSwap router. To accomplish this, we need to instantiate the SushiSwap router contract in our contract. And to be able to do that, we need to include the SushiSwap router contract interface in our contract. With these two things set up, we can now call the router contract constructor and provide it with the router contract's address. With all that in place, we can now call the functions of the router contract. And as with JavaScript, we still need to approve the router to spend the funds. This is like always necessary in JavaScript or in Solidity, it doesn't matter. And in order, so yeah, if we want to execute triangular arbitrage, we could simply use the path argument of the swap function. So we don't have to do 3 swaps. We don't have to call like 3 swap methods in our contract. We can just use the path argument. I think it's a good exercise to figure out why that is. Yeah, I made a small list of things to look out for, some tips and tricks to defeat this challenge. As I mentioned earlier, you will have to call functions of the router contract. So take a look at its ABI and its functions, see what inputs they require, what outputs they give. And keep in mind that not all currencies have 18 decimals. So when I work and I test my code, or I test anything with tokens, I usually test with Sushi, but also with USDC, because USDC has 6 decimals. So it's a good case to see if my code works with a token that has non-18 decimals. If you're swapping a non-native token, the token will have to be approved first. Yeah, that's just common sense. And we have another repo, which is called SushiSwap SDK. This repo contains a lot of convenience classes that can make your life a lot easier. Currency amount is a good example of this. This class will handle decimals for you. All you need to do is provide it with a currency class, which is also provided by the SDK, and an amount, which can be a string or like a big int or anything. We also provide a trade class in the SDK. So while finding the best route is not mandatory for this challenge, I do recommend looking into how it works. You can find the code in the Sushi repo, obviously. Trade.bestTradeExactIn or trade.bestTradeExactOut could be really helpful, especially as these functions return a trade class. This trade class can be used as input for one of the static methods of the router class in the SDK. Last but not least, in both cases, whether it be front end or from a contract, you will always call the same function of the same contract, which is the router contract. It's just in a different context. Yeah, that's it for challenge 1. I guess Sarang is up next.
Awesome. And would you mind answering just a couple of questions that people had
Yeah,
in the
sure.
chat regarding this challenge? Awesome. So first from
Mm,
Citadel. Mhm.
I'm looking for the chat. I'm
Oh,
really like
perfect. I
a
could read
noob
them
with
out to you
the.
as well if that works.
Oh yeah, I found them now.
Awesome. So
Uh,
the first one we had was, could you share any examples that you might have a previously built sushi dApps?
um, uh, I'm not exactly sure what is meant by sushi dApps. So some examples as for this challenge, for the swap challenge, I think the best way would to just be to just inspect the sushi swap interface, because this is just a live example of how everything works. I mean, there's a lot of complex advanced stuff in there as well, but yeah, I think it's you should be able to figure out how to instantiate contracts and how to call them and how to perform a swap. Yeah,
Awesome. Awesome. Thank you. And second, we had, what is the difference between hooks and Redux?
good question. So Redux is a library, and with Redux you can kind of like Redux is for state management, so for global state management. So with Redux you can basically like uh, share state between different components that are like living in completely different parts of your app. So, and hooks are just uh, functions that you can use hooks to like to retrieve parts of the state from Redux. So they kind of use each other. Yeah, so Redux is for state management, and hooks you can use to retrieve parts of the state. But hooks you can also like use for different things. Yeah.
Awesome. Awesome. Yeah, thank you. And next we had, how can Web3 interact with a smart contract?
Ooh, so this all happens under the hood of Web3. Um, I haven't like actually looked into Web3, the library itself, but I think it kind of like transforms the calls to JSON RPC requests. So you use like yeah, an RPC provider, you just send requests to it, and then the RPC provider translates it. But correct me if I'm wrong, I'm not 100% sure about this.
Yeah, so next we had, why do different currencies have different number of decimals?
I honestly have no idea. I wish they all had 18 decimals as
No
well. It would
worries.
have made my life a lot easier.
Definitely. And I had one come to me privately asking if they need to build out a front end for this challenge, or is it just a smart contract?
Um, I think no, you can just build like a very simple front end that swaps,
Great.
or a contract could be. Yeah, it doesn't really matter. Yeah.
Awesome. And one more, I believe. Can Remix Editor be used for deploying the Sushi Swap contract?
You can use Remix to deploy. Sarang has to maybe answer this. Correct me if I'm wrong, but I think you can use Remix to deploy your own contract that uses Sushi under the hood. Yeah, I'm pretty sure, but
Yep, you're
not
right.
100%. All right, cool. Thanks. Thanks for confirming.
Great. And I believe that's all of the questions that we had for this challenge. So thank you so much for that overview. And Sarang, we'll move on to yours with the medium challenge, with the BentoBox challenge. So whenever you're ready, if you want
Awesome.
to go ahead and try sharing your screen.
Yeah. Can you
Perfect.
guys see my screen?
Yes, we can. Looks great.
Awesome. Just a sec. Yep. So, hey everyone, I'm Sarang and I'm a co-developer in the Solidity team at SushiSwap, and I'll be presenting challenge 2, which is building Dapp on BentoBox. So BentoBox is basically a kind of an infrastructure layer that Sushi has actually built so that other developers can come and build dApps on top of the BentoBox. It is basically a token vault which kind of generates yield for the people who deposit tokens on BentoBox via your DApp or directly. It provides better capital efficiency. So you can think it of like a bank, right? So when you go deposit your money at the bank, you can use your money elsewhere. Plus your money also earns some amount of interest, right? So it acts like a savings account. And with BentoBox, we have something known as strategies, which actually work towards making the tokens deposited in BentoBox as a yield bearing tokens, because any token that you deposit, like say you come and deposit like say 100 USDC in BentoBox, it will be actually used in a strategy such as like depositing these 100 USDC in something as like Aave or Compound, and your tokens will be actually earning yield while they can also interact with other different applications that are built on BentoBox. So it is like something like an blockchain app store plus a savings account directly built for your dApp on Ethereum via Sushi. So there are different things that you can do with BentoBox. The first thing is that there are a lot of strategies, right? So any token that you deposit via the dApp or directly into the BentoBox, strategies can use that to actually generate more yield. So there are a lot of strategies that we are planning to integrate, and this is basically a community effort. So you can come up with your own strategy, and we can use that for the token. So one of the strategies is depositing the Sushi tokens into XSushi. The other strategy is using these tokens into the compound and getting some yield out of there. The second big advantage that you get using the BentoBox is the gas optimization, right? So in a traditional dApp system, right, when you go to a new dApp, if you're interacting with 3 tokens there, you need to approve all 3 of those, right? You go to a different dApp, and if you again interact with all those 3 tokens, and you need to again approve, right? So there are a lot of blockchain calls, and you need to pay a lot of them, and which is something that is actually wasting the money of the users, right? So here's the power of BentoBox, right? You just approve all these tokens to the BentoBox once, and then all these dApps with the user's approval can actually get the access of all these tokens. So you just approve to BentoBox, or like say if you have 5 tokens, you just approve it to the BentoBox. And any other dApp which wants to use this would first ask for your permission just once. Once you give the permission, this dApp has access to your tokens. So any new dApp you go that is built upon BentoBox, you just need to give that permission, dApp permission once, which is also a signature-based permission. So you can actually batch it, and that comes to the third part of the benefits, that you can actually batch a lot of these calls into BentoBox, making it just one seamless transaction for the user. This actually increases a lot of UX. One other thing that you also get with BentoBox is how you actually transfer different values, a different token value inside BentoBox. So if there are dApps built upon BentoBox, they can actually directly transfer tokens within each other, and which is in a more gas optimized way, because unlike the other way, you actually have to do an external call where you actually interact with the token contract. In this case, because BentoBox is a token vault and all these tokens are held within BentoBox, it's just a balance chain inside it. So what we're looking for is basically like any dApp that you want to build on BentoBox, and BentoBox is just a layer which on top of which you can build anything. So sky is the limit, but we have few inspirations for you. You can build a crypto indices space. You can build a prediction market. You can build derivative platforms. You can even build something like Savior, right? So if you have used Savior to receive funds, right? Imagine if you build Savior on BentoBox, you'll be receiving funds plus an additional fund, because the funds that are saved in BentoBox keep generating yield and APY for your tokens stored, right? You can even go for a multi-sig treasury management / DAO. And you have seen like DAOs are getting very popular, and they store huge and enormous amounts of fund, right? So why not store them in BentoBox and get more yield out of the money stored in these DAOs, right? Now coming to the big question, right? How do you actually integrate BentoBox in your dApp, right? So the first step to integrate is register your protocol with the BentoBox. So I don't know if you can see my mouse, but yeah. So basically you call this register protocol in our BentoBox contract. And once you call that, your dApps gets registered with BentoBox, and your dApp can seamlessly use it. The other thing is once the Dapp is registered with BentoBox, right, you still need to have users' permission. So users would actually sign this transaction, approving your Dapp to spend their funds. So your users would need to call set master contract approval, or you can even call it in a batch fashion where you call this first and then the operations of your Dapp subsequently. So this is a very important step. If the users do not do this, your Dapp cannot access it because BentoBox is created in a very secure manner that I'll also talk about later. But just to give a context, BentoBox do needs users' permission to actually let their funds access to your Dapp. The third step is if the users do not have any funds at the BentoBox, like say they're the first time users, right? You can use this deposit function to actually take the tokens out. Like if they have some 100 USDT balance, right? You can actually take that and store that in the BentoBox that your app can use. So for this, you would actually need to call the deposit function. In the same manner, if you need to transfer the tokens within BentoBox, so you would use transfer. One thing that you need to be careful about this, that this is not a transfer from like at the token level. This is an internal BentoBox transfer. So any transfers that you do here would be inside BentoBox, which actually is a much gas saving and it's also easier to deal with. The other thing is withdraw. So once your user has interacted with your app and they want to take out their funds with the yield that they have, extra yield that they have got by using the BentoBox that is built up that BentoBox and your app, they can call withdraw. Withdraw would actually withdraw their tokens from the BentoBox and send it to their wallet. So just a recap of what we did. So you can build like any Dapp, and any Dapp that you build with BentoBox will have this unique advantage of a marketing boost with Sushi. BentoBox is extremely safe and well audited. If you would look at, right, we need a lot of users' permission as well. But all these things built is well audited, and it's actually safer to use those kind of contract and not reinvent the wheel. Because if you would try creating new logic with the transfers in your contract, you might end up writing a vulnerable code. So as BentoBox is very well audited and battle tested, you can just use BentoBox for these purposes. BentoBox also has a time lock functionality. So any new strategy that comes into the BentoBox potentially has to go through a strategy which has a time lock, which basically makes sure that there are no malicious strategies that can come into the play. So yeah, I'm up for questions.
Let's see, I believe we had one here in the chat earlier. Let me get that pulled up. We had from Carlton, who approves bento dapps?
So there's no approval for bento dapps. So you can just create your bento dapps. It's like completely free. There's nobody from the Sushi team that needs to approve it. BentoBox is completely open. You can come build your Dapp on BentoBox without anybody's intervention. In terms of users, if users have, like, if you're talking about in the perspective of users, and users have their funds in the BentoBox and they need to approve your Dapp, they need to call this set master contract approval function to give your Dapp the necessary permission to spend the tokens.
Awesome. And is BentoBox available on Polygon? Was a question that we had.
Yes, the BentoBox is available on Polygon, I believe.
Awesome. Great. And another question, could you possibly share some bento dapps at the moment, and what marketing support is there?
Oh yeah, really. So one of the bento apps that we have is Kashi Lending, which is a risk minimized ISO lending built up on top of BentoBox. So you can go to the bento, like once you go to Sushi, there'll be a BentoBox page. If you click there, you could find like a very nice app story kind of a view where you could see our first app as Kashi. And there would be more apps that would be coming soon. So possibly any app you build, we can actually put it up there for anybody else to use it as well. And that would be also a marketing boost, right? So anybody using Sushi can potentially see your Dapp. But I think like if Amanda is in the call, she might be able to, you know, describe much more on this.
Great, great. And we had one, is BentoBox kind of like a blueprint?
You can think it in a way where, you know, like BentoBox is the de facto layer that you build your Dapp upon. And all those operations for you, like transfer, deposit, and withdraw, are abstracted inside the BentoBox, so you don't have to worry about that. And you just build your own Dapp. and like just play around with BentoBox to see how these works. And BentoBox abstracts all these complexity for you.
Great. Awesome. And that looks like all the questions that we had for this challenge. So thank you so much for another great presentation. That was great. And next up, we have Gasper from Sushi to talk about the analytics challenge. So if you want to go ahead and try to share your screen, Gasper, and we can go ahead and get this third presentation started.
Hi, everyone. Can you hear me?
Yes.
Okay, just a second.
Perfect.
All right, hopefully you can see my screen.
Yes, looks great, just about.
Well, first, let me just say it's nice to be here. Hello, everyone. My name is Gasper. And same as Sarang, I'm a core Sushi Swap developer. We joined earlier this year. And I will be talking about the third challenge, which is building some multi-chain analytics. And the goal here is to uncover some insights regarding our user base and activity on all of our networks.
Hey,
so
Gasper, just a second.
Yes?
We cannot see your screen, it looks like. It says that you started screen sharing, but the screen looks just to be blank. So if you want to try unshare and then try sharing here. Interesting.
How about now?
It still seems to just be a blank screen on my end. Let's see.
Oh, maybe in that case, Sarang or Ramin can share a presentation.
Yes.
Yeah, sure.
Perfect.
Let's see.
I can just give you a link quickly.
Yeah.
Great.
Cool.
Thank you. Perfect. Looks great.
All right.
So as I was saying, as I mentioned, she's deployed on 17 chains at the moment, and it's really attached to keep analytics across. So currently, we can view all of our analytics pages on our SushiSwap sushi.com website, and every analytics page is a subdomain. So we have analytics.sushi.com, and then we have analytics-polygon.sushi.com, and so on. And you can see the example of our page, and it's an old page. This is what's currently live, but we are preparing the next version. But still, the key focus of the challenge, creating cross-chain analytics, is yet to be done. Okay, so a quick word about how we currently get our analytics. We use, if you can just move on the next slide. And the next one. So we use the graph, and the graph is a decentralized protocol just for querying the Ethereum networks. So it uses well, first let me say this. Querying the database, well, it's usually very simple with what we're familiar with. We have our own backend, we have our own database, and we can just fetch any data we need. But with Ethereum, this can become very complex. So in some cases, the data we need is easily available right from the blockchain. So if you have a specific user and we want to know what is the balance of sushi of that user, that is an easy query. We can just call the sushi contract, pass in the user address, and get the data we need. But if you're asking yourselves, who are the users who have the sushi balance that is greater than 100? Well, this then becomes very difficult because you would need to traverse all the basically all the relevant blocks in Ethereum and manually figure out that data yourself. So here comes the Graph protocol, which makes this process much easier. So in essence, this is an indexing protocol. So what developer indexes, or they are called subgraphs. And what it does is then it listens to specific events on the blocks, and then it saves or it stores just the data that's necessary, so it then can be later easily fetched. And then another note on the graph, it works, maybe if you can move on to the next slide. It works using GraphQL, and you might not be familiar with this, but this is basically an alternative to REST. So we've mostly all used REST by just calling some API endpoint and then receiving a bunch of data. But GraphQL works a bit differently. And here you actually define what data you need. Then the graph or the GraphQL then returns you just the data that you ask for. So if you define, in this example, the name, you will just get the name. Or if you define the height and the mass, you will also get height and mass. So it's a really efficient way of querying, but it's also really intuitive. So it doesn't get much effort to figure out how it works. Okay. Next slide. So as I mentioned, the graph works, the graph is based on subgraphs. So subgraphs are cache some data that you need, and SushiSwap has a bunch of subgraphs, as you can see. So just for the exchange itself, we have a subgraph for each layer 2 or each secondary network that we are deployed to. Then for BentoBox, we have subgraphs for XDAI, Polygon, Phantom, and BSC, but not for other networks as we haven't yet deployed there. But just as an exercise, I would suggest that you go to the Graph website and use their Explorer, or recently it has become a legacy Explorer, and try playing around with the subgraphs. I wanted to do a live presentation, but I guess it's not going to be possible. But I would invite all of you, if you are building the challenge, to visit the website and play around with the Explorer, because it's actually really fun. You define all the information that you need, and you get the data straight from the blockchain, basically. And there is another link here. And it's a link to the SushiSwap interface GitHub repository. And this is actually the latest version of the graph that we use, or I should say the graph implementation. So if you want to get all the other endpoints and just see how SushiSwap uses analytics, please refer to this repository. Okay, next slide. So here, there's an example of a GraphQL query. And the goal here is to get addresses of pairs where token 0 or token 1 is the sushi token. So you may be familiar with this, but if not, so SushiSwap Exchange basically has a bunch of pairs. And each pair is then enables trading. So you can have like a sushi Ethereum pair, or maybe a sushi USDC pair, or an Ethereum Rabbit Bitcoin pair. And so in this example, I've written a query that fetches all the pairs where sushi is a part of it. And it works. It works actually surprisingly simple because you just need to pass the address of the sushi token in the query. So it's pretty self-explanatory. So you define, you say you want to get the pairs data, then you just pass in a filter. So where token 0 or token 1 is the sushi token. And then in response, you get an array of all the pairs that include the sushi token. And you can just use that string in the result as that string is basically the address of the pair. So with this query, you could get the count of all pairs that include the sushi token. Okay. And the next slide, it's another example, but oh, I should mention that the previous slide was from the Explorer on the GraphQL page, which I did want to show. And you can check it out for yourself. It's really nice. But the next slide is an example from basically what you will do from the code. And it's just some JavaScript code. And the goal here is to get addresses of unique sushi buyers in the last day on the Ethereum sushi pair. So if you first analyze the query that we're sending, so we are asking for all the swaps, but then we narrow it down. So we want the first 100, and we don't want to skip any. I will touch more on this later. Then we say where the pair is the address of the Ethereum sushi pair. So you can find the pair address with another GraphQL query, or just look it up on our analytics page. And then I say, and the timestamp has to be greater than what 1 day ago. So it will fetch all the swaps from the last day. And then in the second part, I just define all the fields that I want the query to return. So I want to have the sender address, I want to have the to address, and I want to have the transaction hash. So I can use this query, and I can just send it to the graph endpoint. So here I'm actually using an REST query. So I mentioned that the graph is an alternative to REST, but the graph service also allows you to wrap your requests in a HTTP request. So that's nice. You don't have to learn any new technologies if you are unfamiliar with the GraphQL. So anyways, here I get the response. It's all the swaps. And there's a thing I would like to point out here. So instead of just getting all the senders from the swap, so maybe I would intuitively just take all the senders and just filter them. So it's only unique senders and then count them. But with SushiSwap, how it works is, well, actually Ramin was focused on this. Traders don't interact with the Sushi Ethereum pair directly, but they actually interact with the router. And that router contract then interacts with the pair. So in reality, if I were to use the sender field here, I would mostly get the router address as the unique buyer. So I would have one unique buyer of sushi today, maybe, or a couple more if people interacted with this differently. So this is just like an important thing that you have to realize, that users usually interact with the router. So an equally good metric is then to just take the to address of the swap. So the users will swap through the router will interact with the pair, and then the pair will send the tokens back to the user. So if you do it like that, you still get an accurate count of the users or of the buyers of sushi in that pair. And that's it for this query. You can just run it, and the result was that there were 136 unique buyers of sushi today. So, and coming back to the query, As I mentioned, you can pass in first and skip parameters. And this is specific to the graph. And that is that they will return a maximum of 1,000 results per each query. And this can quickly become a problem, especially if you're doing big queries as is going to be required for this challenge. So you may be querying for all the swaps on all pairs for the past month, and that's going to be hundreds of thousands of results. So in that case, what you would have to do is run a bunch of requests.
Gasper, can you hear me? Seems like the audio might have went out there for a second.
Until you exhaust all the swaps. Yes, that's and I think that's it for this query. And now for the next slide to recap what we're looking for. User insights. So how many wallets used the SushiSwap exchange each week, month, or quarter? And then we would also really like to see some combined analytics, such as value locked and volume across all the chains combined. So if you would write those queries, and then maybe assemble them in a nice chart, that would be really excellent. And yeah, I think that's it. If there's any questions, I'll be happy to answer them. But otherwise, I wish you all good luck and thank you for participating in the hackathon.
Awesome. Thank you so much, Gasper, for another great presentation there. We do have just a couple of questions. So first, are there any particular skills that a hacker would need to use the graph?
No, I would say that it's surprisingly simple. So I wanted to use the Legacy Explorer on the Graph website to really show how simple it is to get the required data. And then you can use my example in JavaScript as a reference on how to actually query it, so you can have it in your code. And I think that's a really good starting point to get all other data that you need.
Great. Awesome. And we had more of a complex one about a query there in the chat. So if you could on your end pull up the chat, and we had one asking about a query and about the ID involved with it.
Oh, just off the top of my head, have you tried inverting the order by parameter? But as for your question, the ID keyword would respond to the actual address of the pool. So that's, you have that correctly. I mean, you understand that correctly. But it sounds like to me that just the results are inverted, that it shows the
Great. And I believe we had one more question here. This one looks like it was about the BentoBox challenge for you, Sarang. Is BentoBox limited to only ERC20 deposits? And can ERC 721 also be deposited? I was thinking about some strategies for NFTs.
I think Sarang is left, so Gasper or Chili, if you want to take this one.
Ooh, that's a good
So-
question. I have no idea actually. Gasper, do you know?
If not, maybe that's one to post in the Discord, and we'll try and get that answered.
Definitely.
Yeah,
So,
Gasper
awesome.
should know this one, but it's probably just a connection issue. I can
Mhm.
find out if you just give me like 2 seconds.
Perfect. Thank you.
Yeah, so it's only ERC20 at this time.
Perfect. Awesome. And I believe that wraps up all of the questions there for all the presentations. So once again, thank you to the 3 presenters today. Those were really good overviews of the different challenges for sushi, as well as Amanda for helping out there in the chat. Those were all helpful to get all those questions answered. But in the meantime, we do have the next Hack Africa workshop coming up on July 26th, and that is the R-Weave workshop. And from there, George is going to be posting the link to the Eventbrite for that event. And then also we do have a survey that I've been emailing out to all the teams. So if you could take just a moment and fill it out, we would love to gain some insight as to what people will be building here for the different challenges and kind of what they're eyeing. And for that, the building phase is actually starting here on July 19th. So if you want to start taking a look at some of the challenges with the teams and maybe pick a challenge to start focusing on. But once again, as always, this event was recorded and will be put onto our YouTube channel as well as our Medium page by tomorrow with the video and slides. So thank you for joining, and have an amazing rest of your morning, afternoon, evening, wherever you may be located. Thank you.